Anyone has experience in doing this kind of stuff in the web browser?
One person with that, very good.
Yeah, no?
Who's used any of the AI and machine learning stuff before? Any takers? That's fine, it's all good. It's a writer talk. Shouldn't need too much background to understand this, it should be fine. Yeah, hopefully this will give you a good overview of what's possible at least, and how you can potentially use it in your industries. So.
Yeah, very good. So very good. We're good to go. So it's my privilege to introduce Jason Mays from Google to talk about that next generation web application.
Thank you very much. So, hi everyone, I'm Jason Mays, Developer Relations Engineer for WebML at Google. And of course, we're going to be talking about building next generation web apps with TensorFlow.js. So the first thing, of course, is that machine learning really is affecting every industry out there, no matter which one you're in. I know there's 3 big ones at this conference this year, but of course there's others out there too. And everything I apply to today can apply to those industries as well. I want to show you this nice little chart, which is quite nice to look at. So we're all familiar with Industrial Revolution and the Agricultural Revolution, all this kind of stuff. And as time versus human progress in terms of technological progress, you can see this is kind of exponential curve that's growing. And the key thing to note is that we're actually at the beginning of the next revolution, which is the machine learning revolution, as I like to call it. And the key thing to note here is that the area under the curve for each segment is more than the last. And in fact, the one we're entering could have more area under the curve than all the others combined. So this is a really interesting time to be alive and to start thinking about these things in the APIs and things that you're developing for your companies and products. So the next logical question then is, why on earth do you want to do machine learning in JavaScript? Well, almost 70% of developers out there use JavaScript right now. So it is the world's most used language. And essentially, TensorFlow.js is a library that you can use machine learning in JavaScript. And that means you can run pretty much anywhere that JavaScript can run, which is basically everywhere. And that means zero install across billions of devices with a click of a link. And because it runs in a web browser, people don't need specialist backgrounds in machine learning to run these applications and services. So here's just a few of the areas that JavaScript runs in. We've got the common web browsers on the left-hand side here. You've got server-side via Node.js. You've got mobile native via React Native and progressive web apps. Desktop native via Electron. And even IoT devices like a Raspberry Pi is also possible. All of these run JavaScript. And JavaScript is the only language that can run across all of these areas without additional plugins and add-ons in order to make that work. So it's quite powerful for that reason too. And with TensorFlow.js, you can retrain via transfer learning or write your own custom machine learning models from scratch using our APIs. And this is pretty cool because TensorFlow.js can actually digest other types of machine learning models as well, such as TensorFlow Lite, MediaPipe, TensorFlow Hub, and also TensorFlow Python models that can be converted to run in the browser as well. And that basically means you can dream up anything you like. And I'm going to go through a few examples just to get you excited. The first one is by a company called InSpace. They are a kind of real-time chat application, video conferencing, that kind of thing. And they're using natural language processing to understand what the user is typing. And if it's something that's maybe a bit toxic, they can actually flag it automatically before it goes to the server for classification and being sent. So you're not wasting any of your server-side resources. It's actually captured on the client side in the browser before it's even ever sent. So my question to you is, how can you use natural language processing in your industry? Because it turns out you can actually adapt this to do other things as well. Maybe you're in the finance industry and you're trying to find stock ticker symbols on Twitter to see what people are talking about. You can understand the sentiment of that and then get a better understanding of the markets for a given area or time. So moving on to the next example, Include Health. Include Health enable remote physiotherapy at scale for many, many people around the world from the comfort of their house using a regular webcam on their laptop or tablets or whatever it might be. Here, they're using a TensorFlow.js model to understand the human pose of a human body. And with that, they're able to understand the range of motion and all that good stuff to a medical quality that they can actually use in production and is live today around the world. Linked to this, we've also got Team Sports, which focus on sports and fitness and that kind of area. So again, it's using one of our body pose estimation models, as you can see in action right there. And this can even work on mobile phones. And you can count your reps, your sets, challenge your friends, get personalized reports, and see that over time, and then become a better athlete overall. And remember, all of this is running in the browser, okay? Google also launched last year at Google I/O an exploration into dermatology, so skin conditions, essentially. And TensorFlow.js is actually part of that pipeline as well. You can see here, we're actually used before the image is sent to the cloud for further processing. We can actually be used in real time on the device to understand if the shot they've just taken has poor lighting, it's blurry, that kind of stuff, so that the shot you then classify and use your server resources to actually process is not wasted, and the user doesn't have to retake a photo and upload it again and again. So, another cool use case. And here's one I made myself in just a couple of days at home because of a problem that I had. I don't know about you, but I'm actually terrible at buying clothing. I never know what size I am for different brands. And you can see here, in a matter of 15 seconds, I stand once to the front, once to the side, and at the point of checkout on the website, it can tell me what thing to put in my basket automatically. And that means happier customers and less returns. And of course, you could reuse this kind of measuring kind of idea in other verticals as well. Now, everything you just saw was powered using our pre-made models. And these pre-made models are really easy to use APIs that you can use in JavaScript in just a few lines of code, ranging from computer vision, human body understanding, text understanding, sound recognition, and a few other things as well for good measure. So I'm going to dive into some of these live so you can just get a feel for these. So the first one is object recognition. Object recognition is essentially the essence of understanding where in an image something is. You've got these bounding boxes coming back, and because of that, you can also understand how many of those things are there. So I'm just going to switch to a live demo here. So let's pray to the demo gods this all works. So this is a website I actually created. This is live on glitch.com. You can actually try this out afterwards. And if I tap on any of these images, you can see I get real-time classifications coming back. Whoops, if I tap on it correctly, there you go. And in under a second there, you can see that this dog is near this bowl of treats. So you could then send yourself an alert very easily when something like that happens. So if you're in the healthcare industry, maybe you're trying to monitor if a patient is going to an area they shouldn't be going to, or staff are going somewhere, what it might be. And remember, this is all happening in the browser, so your privacy is preserved. None of these images are being sent to the server for classification. So now, when I enable my webcam here, you can see me live here today. Oh, it's even detecting the one behind me as well. It's detecting me as a person quite comfortably, and it's running in real time on my laptop, which is actually 5 years old and doesn't even have a graphics card. It's very old, Ultrabook, but it's still working pretty darn well. And remember, all in the browser in JavaScript. No data is being sent away from the device. Oh, a sneak peek of the next demo. Let's go back to the slides. So, next up, we've got text toxicity detection. This is the model that InSpace we're using that you just saw at the beginning of this presentation. So you can see here, for a given sentence that you pass to it, you can see if it's an identity attack, an insult, obscene, and so on and so forth. Now, you might not always want to use those classifications. You can actually train your own versions of this model to do things like sentiment analysis, or if something's bullish or bearish in a stock market, wherever it might be. Or imagine if you could, I mean, everyone here has probably got a contact form on their website, right? And you can understand the context of what's been put into that contact form. So now you don't have to read it. You can send it to the right team automatically and save time for your employees not reading all those emails. So think about how you can apply this to your industry. Or we've also got speech command and audio detection, so short form, like a couple of seconds in length. And that's actually very good to be able to detect maybe if you're in healthcare, if someone's in pain, maybe they are crying or they're screaming or something. And I know there's shortages in staff these days, so maybe you can actually alert someone to go and check on that person if that's detected. And remember, again, this is all privacy conscious because none of those audio sounds will ever be sent anywhere. It's just classified locally on the device, and you can just send an alert to go check in on them. We've also released a new model called selfie depth estimation, which allows you to understand more information about the human face. So for every pixel in the image, you're going to get this depth map that comes back, this nice colorful image, essentially, which represents how deep in space that pixel it actually is. So with that, you can get a 3D model of the face very easily. And that can be used in whatever way you wish to drive whatever application you might want in the future. And linked to the face here, this is another one that I love to show. It's called Face Mesh. It's just 3 megabytes in size, and you can see it in action on the left there. And it can recognize 468 facial landmarks on the human face. And notice on my desktop at home, this is running at 135 frames per second. And my desktop is not the latest thing in the world. It's running at NVIDIA 1070. It's not the latest generation stuff. And it's still getting that performance in the browser, in JavaScript. And we're starting to see companies around the world now take this and use it in real-world production applications, like L'Oreal's Modiface, which has made this augmented reality makeup try-on application. The key thing to note here is this lady is not wearing any lipstick. She can swipe through the available swatches at the bottom there, and now she can try on stuff from the comfort of her house without having to go to the store, which is particularly timely in these kind of COVID times that we're living. So let's just show you that one in action because it is quite cool. And here it is live today on my much, much less powerful laptop. You can still getting 22, 25 frames per second as I'm talking here and doing other things as well. But notice the granularity of my face here. I can open and close my mouth, and I can squint my eyes. So again, if you're thinking about healthcare, maybe someone's paralyzed, and you can actually have a way for them to communicate with you to alert you they need attention or something. And you can then send an alert to the nurse to come and check in on them, for example. So think about how you can apply these things to your industry. OK, back to the slides here. Whoops, there we go. Slideshow. There we go. Linked to all of this detection, we've also got hand pose estimation. So 2D and 3D tracking is possible for, I think, 17 key points on the hand, as you can see on the left-hand side there. And of course, that means you can now start to do human-computer interaction. I can swipe my hand and control an interface remotely. Maybe I'm a surgeon and I can't touch it because I've got messy hands for other reasons. I can now still interface with something and do something useful. You can even use this for sign language detection or other things along those lines. And it can track two hands at the same time in 2D or 3D. Keeping on that kind of riff of estimating poses and things, this is for the full body. This is exactly what Include Health was basically using at the beginning of this presentation. You can get the 2D estimation, what you see here, or the 3D version of that as well, which is localized to a coordinate space that's based around your waist. Essentially, it recognizes 33 key points and can run at over 150 frames per second. Most cameras are capped at 30, so it's the camera that's a bottleneck, not the machine learning in JavaScript. And remember, this is all running in the browser. Linked to this, we've got full body segmentation as well. So you can see here, in addition to the pose, we're also able for every pixel in the image to understand what's the actual body versus the background. And that's useful if you want to maybe blur out people in a video stream or something along those lines in order to protect their privacy. And a good example of that in action is, well, with a bit of creativity, this is what I get up to in my weekends. In one day of coding, I managed to remove myself in real time. On the left-hand side, you see the real stream. On the right is the output of the system. And notice when I get on the bed still deforms. It's actually a live image, but you don't see me. Well, you do slightly. This is using an old body pose estimation model, which has now been updated, as you just saw. So the new version will work much better than this and much faster. But you get the principle that you can actually remove things in real time here. And again, all of this is in the browser. I also tried to think about what the future of communication would be. So I've decided to try and do some teleportation. And here I can take my body from scene A, transmit just for segmentation to be efficient, and then place it using WebXR anywhere else in the world on a mobile device. And in the future, that's going to be AR glasses, of course. So in the future, I'll be talking to you, maybe for a pair of AR glasses. You can plonk me wherever you like, and I can be there and have a presence with you. So human-computer interaction. We spoke about this very briefly a second ago, and here it is in action. One of the people from our community has already done this. So he's got a touchless interface, just a website. That he's running the TensorFlow.js hand pose model that you just saw. And now we're able to interface and check out this burger because everyone's hungry. And I know cocktails are coming, so I won't be too long. And basically, you can now do this. So again, back to that surgeon example. You're in a medical situation, messy hands, can't be doing touch screens. That's not hygienic. You can now just swipe things or gesture to get something happening in that scene. Another demo for this. This guy's based in China. He's doing real-life kiosks for touchless interfaces in China for in retail stores and that kind of stuff too. And the other thing I want to point out here is that JavaScript is not just about the web. We can integrate with hardware as well. This is the first Kickstarter that was powered by TensorFlow.js, and it allows you to track people when they're playing sports to keep them in the center of the frame. And of course, that's using just one of our object detection models to detect the person, and then it adjusts using either Web Bluetooth Low Energy, Web Serial, or Web USB. You can use any of those APIs to then control the hardware that you create. So, a lot of demos, and you're probably wondering at this point, well, that's nice, Jason, but how hard is it really to use, right? So here's an example for text search using a model but with a very fancy name, BERT Q&A. All it means is it's a natural language processing model that can find the answer to your questions. And here it is in action. So I turned it into a Chrome extension, so I can ask a question, what's the best stargazing days? And it's going to search the web page and scroll me to the answer. And notice, stargazing is not in the answer. So I'll do it one more time there. What's the best stargazing days? And look for the word stargazing in the answer. It does not exist there. So it's more advanced than a Control F. It really understands the human language on the page and is still able to infer the correct answer on the page to then scroll you to it. And you can imagine using this in other professions as well to go through very hefty documents that you really don't want to read and find the bits that are actually interesting to you and just read those segments and so on and so forth. So how did I make that? Well, before I go into that, how many people here are from an engineering background and how many are not? So engineers, put your hands up. Okay, quite a few. And non-engineers, I guess the others. Okay, cool. So basically, if you're not from the engineering background, the key thing is that this fits on a single slide. So if you give this to your engineers, they can use this very, very quickly. So I'll walk you through it. Essentially, the first 2 lines of code here, the first line imports the TensorFlow.js library. The second imports the model that you want to use, in this case, the question and answer model. We then define 2 variables. The first one is the search text. So this could be the text on the web page. Just grab all of that and put it into a string. Boom, there you go. And then the second one is a question. That could be taken from an input box, for example, like you saw in my demo. Once you've got those 2 variables, you can then call Q&A.load. That's the name of the model we just imported. And because this might be a couple of megabytes in size, it will take a few seconds to do, you use the then keyword in JavaScript to wait for that to finish because it's asynchronous. When it comes back, you'll get a model variable, and that's the model you can then use. So now we can call model.findAnswers, and we pass to it the search text and the question that we just defined above. And that's going to take a few milliseconds to execute. It's quite fast, but it still takes some time. So we use the then keyword once again, and you get an answers object coming back. And of course, you can then log that out or look at the answers and do whatever you want with them, inform the user what you found. And that's all there is to it. So in basically 5 lines of JavaScript and a couple of imports, you're using machine learning in your app, okay? And that's how all of our pre-made models work. Very simple to use. So the other way you can use TensorFlow.js is via transfer learning. And essentially, this allows you to retrain a model that already exists on a similar but different domain. And the best way to show you this is just to show you it in action, okay? So here we go. And under 30 seconds, I'll show you how to recognize any object. So this is a website called teachablemachine.withgoogle.com. Feel free to go to it on your laptops if you have one. Click on Image Project here, go to Standard Image Model, and we're going to have 2 classes. Now, I'm going to call this one Jason because I'm available right now. So that's the first thing we're going to recognize, Jason's. And the second thing, I'm going to do hand, like so. Jolly good. You enable access to the webcam. And now you can see a live preview of me in a second when it loads up, hopefully. Come on. There we go. So remember, this is all running in the browser. I'm just going to get a few samples of my head moving around here. There we go. Nice. About 36 images. I'm now going to do the same for the hands. Just bear with me a second. Roughly the same number of images, about 36. That's close enough. I'm going to now train a model live in the browser. So I've got a model that already knows how to recognize cats and dogs and things like that. We're going to chop the top of that model off and retrain those top layers to now recognize Jason's and Jason's hands, okay? And this is happening live in JavaScript in the browser. This is not using the cloud at all. We're actually training these models in the browser. And you can see in under 30 seconds, we've got a model that's produced, and it's recognizing Jason with 100% output at the bottom there. If I put my hand here, it says hand, Jason, hands, and so on and so forth. And look how fast that works. Now, if that is useful to you, you can click on Export Model, as shown here. You can click on Download, and you can then download the TensorFlow.js model files, add your own nice, shiny user interface, deploy it to your website, and boom, you can use your API there to then launch that as a demo for your next VC meeting, whatever it might be. So that's how you can use transfer learning very effectively with TensorFlow.js in the browser. Moving back to the slides. Jolly good. So the third way you can use TensorFlow.js is to write your own code. And I've got a whole course about that. It'll be much more than a 20-minute talk. But I want to give you the highlights here of why you might want to consider doing that. The first thing to note is we have some APIs, of course. And we've got 2 APIs, in fact. We've got the high-level layers API, which is like Keras, if you've ever used Python-based TensorFlow. And you've got the low-level ops API, which is more mathematical in nature. If you're trying to invent the future and get down and dirty with that linear algebra and all that kind of stuff, you can do that as well. So putting this all together, then, you've got our pre-made models that you saw today. They are built upon the layers API, which is sitting upon the core or ops API. And then that understands how to run in different environments, like the web browser on the client side. You then have different backends. And by backend here, I do not mean server-side. I mean the hardware you're executing on. That's a special ML term. Essentially, you can run on the CPU, which is plain old JavaScript. You've got WebGL that gives you graphics card acceleration in the browser. And you've got WASM, or WebAssembly, which allows you to execute assembly code in JavaScript on the browser. So essentially, those are the 3 ways we get very fast performance with TensorFlow.js on the browser side. The flip side of this is we've also got server-side execution via Node.js. So if you are wanting to stay on the server side in the cloud, that's fine too. We've got Node. And that's got the same TF-CPU and TF-GPU bindings as the original TensorFlow Python does. So the speed is actually the same or faster than TensorFlow Python because of the just-in-time compiler of JavaScript. So fun stuff. And if you are using TensorFlow Python and want to keep using that, that's completely fine too. If you have saved models from TensorFlow Python in the cloud, you can run those in Node without any conversion. It works just fine. But if you do want to convert your Python models to run in the browser, we've got a command line converter you can use to do that. And then you can run those models in the browser as well. And I just want to talk a little bit about performance here. So in Node.js, you can get up to 2 times faster performance than Python. This is a very famous case study here with Hugging Face, who are very famous for natural language processing in the industry. And they converted one of their models, and you can see the difference in inference times. That's the time to classify something. So why would you want to convert to the client side then? Well, you get some superpowers if you do that. The first one, as we kind of hinted at throughout this talk, is privacy. None of the sensor data, the imagery, the sound, audio, whatever it might be, is being sent to the server for classification. So in certain countries and certain industries, that's really important. Second point, because you're not talking to the server, you've got lower latency. Instead of taking 100 milliseconds to go to the server and back again to get an answer, you're going to get it in under 10 milliseconds maybe, or something like that. So you can do real-time applications. That also leads to then lower cost. If you're doing machine learning in the cloud, you've got to pay for expensive GPUs, RAM, processors, and so on and so forth. And then the fourth point, interactivity. The web from day one was built for interaction. That's what the web exists for. So we've got very rich libraries to make graphical user interfaces, 3D graphics, and all that kind of stuff very, very easily. Fifth point, reach and scale. Anyone, anywhere with a link, like you just saw, can try it out and use it. So with that, you can get productive very, very quickly. So I'm going to end with some resources if you're inspired by anything you saw today. First thing, if you've got any engineers interested in this subject, I've got a free course on edX that takes you from 0 to hero. No background in machine learning is required. All you need is some passion and some love for JavaScript, and you'll be good to go. So go to guru.gle/learn-tfjs to get that. I've also got this this slide to bookmark. Basically, check out our website, TensorFlow.org/js. You can see all the other models that I spoke about today there too. We're completely open source, so check out our GitHub code. We welcome contributions. We've got a forum for more technical questions, should you have any. And we've got code examples you can fork in minutes to have boilerplate code to start from. And if you're looking for more inspiration, check out my YouTube playlist on this link. Short 10-minute bite-sized interviews to get inspired what others in the industry are making. If you prefer books, the 2 books on the right are my recommendations. The O'Reilly one if you're a beginner, and the Deep Learning with JavaScript if you're a bit more advanced. So other than that, come join our community. If you make something in your industry using this, use this hashtag so I can find you and feature you on our show and tells and things. That would be great to nerd out with you some more. And the only thing left to say is, what will you make? Machine learning really now is for everyone. I end with this slide from a guy in Tokyo, Japan, who's actually a dancer, but he's using TensorFlow.js even for his projects. So it doesn't matter what your background, even if you're not an engineer, you can now start to use machine learning in your industry and use our APIs to take your clients to somewhere that's much more advanced than where they are today. So with that, thank you very much. I'm Jason_Mays on Twitter. I'll be on LinkedIn or Discord. I can take some questions now. Thank you.
Wow, Jason, that's beautiful. I love the demos. I love all the, it's tons of information out there to learn. And really, when we talk next generation, this fits the bill for API days, talking about next generation stuff. The edge now is everywhere. There's no more edge anymore. Any questions? We do have some time for questions. Anybody have any questions?
I know there's cocktails coming, so I understand. It's fine. But yeah, if you want to talk to me in cocktail hour, I'll be around as well. But yeah, if anyone.
Yeah, I do have one question about the. You mentioned open source and having TensorFlow as an open source, a framework, and all that. And how about the models themselves? Yes. Are they also open?
Yes, we released those on our GitHub repositories as well. The original training data is not necessarily public, but the model architecture and the model itself is available on our GitHub for people to take and use in their whatever application they want to use it for, basically. So that's fine. Yeah.
Okay, great. And you listed a lot of good resources. I'll look forward to look at some of those to learn more about what's ready-made, already trained models that are out there. It seems like
that can save you a lot of time as well, especially if you're a startup or something. The cost of developing a model from scratch can be significant. You've got to get all the training data. You saw recognizing my face and my hand in under 30 seconds. But of course, if I asked someone with a different type of face to come up and try it, maybe it'll be like slightly less accurate. So you want a lot of training data to be avoiding any biases and things like this. But that's what takes the time, actually. So making the model is the easiest part. Getting all the data is the hard bit. So start recording that data early on for whatever industry you're in. Maybe it's, the log files for something or whatever it might be, and just collect it and then figure out how you can use it to do something cool. So, yeah.
And that brings another question on the privacy of the trained data, right? Like
Yeah.
in the browser, it's within the browser, but now when you start to share that data of trained agents now on the server side, how do you answer to that concern, or is that some kind of a where to draw that line of privacy or knowing what we're doing when we're sharing
that's a great
some of those
question.
training?
Yeah. So at Google, we will typically source the training data ourselves. We will hire companies, like if I need 1,000 images of cats, I'll go and pay someone to go take 1,000 images of cats for me, and we get all that data. So it can be costly. If you're using existing data sources, then you should make sure that it's within your rules and regulations to be able to use that data, and it doesn't go against your terms and conditions to then turn that into some kind of machine learning model to use as a service and potentially monetize from that as well, right? So that'd be down to your individual rules and regulations for the companies that you're working at. I don't know all of those, but yes, do think about those things. But yeah.
Yeah, great. Thank you.